I'm Anil Kumar, and in this video we are going to understand how ordered pairs and relations are related. As you know, ordered pairs are set of numbers or coordinates which could be written as within parentheses x comma y, right? So that is what we call as an ordered pair, right? So let me write it down. What we say is an ordered pair is a set of number or you can say coordinates. These are x and y coordinates, right? Or coordinates. And they are written as x comma y. So let us get back to the coordinate system and understand what a coordinate system is and how to represent these ordered pairs. And then we will see how are they related with our topic, which is relations. Now when you're talking about a coordinate system, I hope you remember a coordinate system has two number lines. One is a horizontal number line and the other one is a vertical number line. So these are the two number lines, and these number lines intersect at point O, which we call origin, right? So these are two number lines. We call this as an x-axis and the other one as y-axis, and their point of intersection, represented normally by letter O, is called origin. Now both x and y coordinates for the origin is 0, 0, right? So 0, 0 represents the origin. Now in this particular case, if I have a point, let me first write down a set of coordinate points. Let's say it is -2, -1, -1, 1. Let's say 0, 3, 1 and 5. Let's consider these 5 points. Now when I put them into these curly brackets, it becomes set of points, and each point here represented as an ordered pair. These are all ordered pairs, right? So these are all ordered pairs, and group of these ordered pairs become a set, right? So it is a set of ordered pairs. So that could be a set of ordered pair. Let me call this set of ordered pair as A. So A is actually, we'll get back to that, is a set in which we have 1, 2, 3, 4 points. Each point is represented by ordered pairs -2, -1, -1, 1, 0, 3 and 1, 5. Now -2, -1 could be represented on this coordinate system. Let me call this a coordinate system. Let me write down the word coordinate system. With 4 different points. First point, let me write this as -2. Let's say this is 1 unit along the axis. So first part is along the x-axis. Negative means negative is on the left side. This is the x-axis, positive. Y-axis going positive upwards, negative downwards. So -2, -1. Let's say this is -1, -2. 1, 2, 3, 4, 5. So this point -2, -1 is here. So that could be -2, -1. Then we have -1, 1. So at -1 we have a point which is 1. Then at 0 we have 3. So at 0 we have 1, 2, 3. Right? So this is my 3. And at 1 we have a point which is, let us say, 5. Now if you join these, so these becomes the points. We are not joining them as they are independent points, right? So these are 5 points. Let me just show them like big and bold. Okay. So these 5, or rather 4 points, 1, 2, 3, 4, are represented on the coordinate system, and their coordinates are -2, -1, -1, 1, 0, 3, 1 and 5. Now the first coordinate is represented along the x-axis. So the x coordinate for the first point is -2 and the y coordinate is -1. So this each unit is, let us say, 1 unit, right? So this is each is 1 unit. Left side is negative. For x-axis, right side is positive, right? So -2, -1. So go along the x-axis 2 units and then y unit -1, 1 unit down. Then for -1, 1, you go 1 unit to the left and 1 unit up. 0, 3 is along the y-axis, 3 units up, and 1, 5 will be 1 unit to the right and 5 units up. So we get 5 points. Now these are called the x and y coordinates, right? So here in this, that is the x coordinate and the other one is the y coordinate. So this is the x coordinate and the other one is y coordinate. So in our coordinate system, we have two number lines. So these are our two number lines. Horizontal number line is the x-axis, vertical number line is y-axis. They cross at origin, and each unit on this number line is marked with positive on the right side, negative on the left side, or positive along going above origin and negative below origin, right? So that is how we have a coordinate system. Now if you place these points, we get those points represented in the form of a graph, right? So this becomes a scatter graph for you. So that is how you can write the ordered pairs or show the ordered pairs on a coordinate system. Now as you can see here, for a value on coordinate system along the x-axis, we have a specific value along the y. So that is how x and y are related. So every point here on the coordinate system represents a relation between x and y coordinates. Do you see that? So this relation between the two values is represented by the ordered pair, right? So we can say a set of ordered pairs is called a relation, right? Because here every element in x is related with an element in y. So that is how we can say that this is a relation, right? And this kind of a relation can be represented in different forms. We could represent this as a mapping diagram. So let me write down different forms in which we could represent this. We could represent this as mapping diagram. In mapping diagram, we have set A, which will say set of x coordinate points. Set B is set of y coordinate points. So we can write -2 is related with -1, and that is how an arrow indicates the relation. Arrow originates from the x coordinates, which we also refer to as input, and the output as -1. You'll recall that on coordinate system, the independent variable is x, dependent is y, and in an output machine we will consider x as an independent variable, right? And then -1 is related to 1, 0 is related to 3, and 1 is related to 5. Correct? So you can make a corresponding mapping diagram showing the relation. The same ordered pair set could also be represented in the form of a table. Let me write it down for you. So we'll make a table now representing the same relation, where x is the input and y is the output. Ordered pairs which corresponds to x coordinates come on the input side, which are -2, -1, 0 and 1. The output is the y coordinate, so it is -1, 1, 3 and 5, right? So this table also relates to the same relation which we had represented earlier with the help of set of ordered pairs, right? At times you can find an equation relating them. So we can have an algebraic equation which could represent the given relation. In this case, what you notice is that for increase of 1 on x-axis, y increases by 2, right? Y increases by 2. So you could write an equation with slope of 2. So we say y equals to 2 times x. Now how do you get the equation? If x is 0, we want 3, so we'll add 3 to it, right? So we add 3 to it, so we get a linear equation. So that linear equation also represents the same relation. However, we should be careful in this case, because here what is x? The input here will say x is equal to these numbers, minus 2, minus 1, 0 and 1. Right? That is kind of very important. So you could represent this set of ordered pairs given to us in different forms, and all these forms will show you that each and every element in the first group is related with the other group, and this relation could be represented in different forms. Could be represented graphically, so that is a graph, coordinate point, right? The coordinate system gives you the graph. Then we have a mapping diagram, a table, an equation. Now when we read about relation, we'll also get across another term where we are using the term domain and range. Domain and range. Let me introduce you these two terms also. Domain in our case is set of inputs. So each we represent them as set of input elements. We use the word elements. So each individual here is an element, set of input elements, and the output is the range. So we could call this a set of output elements. So in our case, domain for us is these values of x, minus 2, minus 1, 0 and 1, and range for us is the outputs, the y coordinate points, which in our case is minus 1, 1, 3 and 5. And these curly brackets represent set or group of. Correct. So in this video what you learn here is that we could represent a relation as a set of ordered pairs, and these set of ordered pairs could be represented in many different forms like coordinate system, mapping diagram, table and equation. So we'll take a few more examples to understand this concept and then move on from relations to functions. I hope that helps. Thank you and all the best.